Hi folks, good to see you online again. Just to answer the question that we've already got already. No, that was not me playing the piano on the intro music. I wish I could play like that, but unfortunately all I can do is tap out a couple of tunes, and that's not included. So anyway, it's great to be here today with Jeff from, you're in the geometry team at SAFE, is that right?
That is right.
Excellent. So yeah, Jeff, I just introduce you a little bit because I don't think we've really sort of chatted or interacted too much before. So you've been at SAFE for how many years now?
Probably approaching 6. I joined as
Six?
a co-op on the order of 6 years ago.
Okay,
Worked as a co-op for a year. Worked part-time while I finished my school, and then yeah, I've been going for a few years now, full-time.
excellent, excellent. Always been the geometry team?
Yeah,
Yeah,
from the beginning.
yeah. I know I've said this before, but I think that's the one that I'd want to join if I was a developer. It just seems more interesting than the rest. So
We certainly have interesting problems.
that's true. Yes, all the coordinates and the geometry. The interactions of the coordinates and things like that it just sort of baffles me sometimes, especially when I talk to Kevin, who's one of the leads there. Yeah.
Yeah,
Anyway, so you worked on this classifier transformer, is that
that
right?
is right. Yeah, originally an Innovation Days project turned full feature.
Okay, fantastic. And so, just so folk know, the Innovation Days is where it's like a week, isn't it? Week-long event where everyone just sort of gets together in the development department and works on various projects that they think will improve FME or safe procedures in some way, and just the sort of things I guess that we don't really normally have time to do. We just take that week to work on them. And,
Very much like a hackathon, like an
right.
internal hackathon. Everyone gets to propose projects that they think would be fun or of interest to themselves, either building on FME or using FME to accomplish an interesting project. And then
Fantastic.
we team up on whatever you find cool and
Yeah.
try
And
to make something interesting.
you're actually taking a break from this week's or this year's Innovation Days because it's on this week.
That
So
is right. We are right in the middle of it this year. Yep.
so thank you for sparing the time to come and join us because I know that's really important to you folks. I'm looking forward to seeing the presentations that you do to us tomorrow. But let's talk about the classifier transformer. So do you want to give me a quick idea about what it does and how it works?
Sure. So
Or the which demo did you have first? Because I think we were going to look at the feature color
yeah, I
setter
think we
as
can start
well.
with that one. It's probably
Okay,
simpler, but
I'll let you lead us on.
either way, the sort of motivation for both of them and for my original Innovation Days project was um, this concept of choropleth maps,
Hmm.
which is something that we didn't have great support for natively. I'm sure you could accomplish it if you were
Yeah,
clever, but
yeah,
it's a type of symbolic map where you color various regions of the map based on some particular value, and you can just do that on a straight gradient. But in many cases, people like to do them in sort of color blocks.
yeah.
Um, and so we introduced two new features for FME 23. The first is the gradient mode for the feature color setter, so you can accomplish
Hmm.
that color grading. And the second is this classifier transformer, which we'll get to in a sec,
Okay,
which you can use to separate your features into those blocks, all of which will get the same color.
okay.
So we can start with the feature color setter, which existed previously and allowed you to select one of a number of color schemes to set your fill or pen color on features.
Hmm.
The new thing here is this gradient mode, which lets you specify a start and end color of your gradient, which you can select from uh, any RGB color. And it will linearly interpolate between those two colors through one of two color modes. You can either have it interpolate across the RGB color space or the HSV color space, and those will produce different um, results, which we'll take a look at.
Okay.
Each of your features provides an interpolation value, which can be read from either an attribute directly or informed through the arithmetic editor to do something more advanced. And that value should fall between 0 and 1, which determines where on the gradient your feature selects its color.
Yeah, I think that's the one that confused me when I first tried this, because I thought, oh, I'll just set it to 0.5 and see what happens. And, well, nothing really happened because all of the features were the same and they all got the same color. So that I think is something for folks to be aware of. It needs to be a different value per color if that's not a different value per feature to get the different colors if that's not clear.
And I think we recently actually added a error or warning. If you do that and you set it to a constant value that won't actually vary across features, you should get a warning.
Oh, okay. Oh, fantastic. That's good.
Because, yeah, that obviously is the entire purpose, is to color your features across the range.
I think a lot of people are like me. They just try things out without reading the documentation first. So, I should say, by the way, any people watching, and there are quite a few right now, just any questions you've got, just put them straight into the chat. That'd be great. And if we don't get to them straight away, we will get to them. Sorry, Jeff, I keep interrupting. So
no, all good. And so this workspace here, just to demo this, creates a number of circles, offsets them for visual clarity, and then we're running them through the FeatureColorSetter, one in HSV mode and one in RGB mode. I've actually just changed it, but the output looks a little something like this. On the top here, we have HSV interpolation. It tends to produce these sort of rainbow effects as the interpolation goes across the hue space. And RGB on the bottom here goes arguably more directly from one color to the next.
That's interesting.
So whatever it is you're after, hopefully you can accomplish it with this.
I think I'd only tried it in RGB mode, so the HSV, that does look surprisingly different. I like that.
It tends to give you more distinct like middle values.
Yes.
Which has their own unique color rather than being sort of a muddy combination.
Yes. That's what I'm thinking. Maybe that will be good for when you're going, say, from green to red, but if you're going from light green to dark green, maybe RGB is a way to give it more of a... That's just a thought anyway.
And so, that's the addition to FeatureColorSetter. Relatively simple, I think, but hopefully useful. The second part of the choropleth map problem was classifying. And so there is this concept in cartography of classifying your features into different sort of clusters that have a similar value so that you can use different symbols, or in this case, different colors to represent them. And to that end, we've added this new classifier transformer. What it does is takes any input features and based on your parameters, assigns each of them to a certain number of classes. You can specify how many classes you want in the transformer. In this case, I have 8. And you can specify the value on which each of the features will be classified. So this can, again, like the FeatureColorSetter, be read directly from an attribute, or it can be informed by the arithmetic editor if you want to do something more advanced. And the features will, based on that value, be put into categories using one of a number of classification methods. And so during my research, there were many different ways to group features based on a value. These 3 seemed to be, by a pretty significant margin, the most common or popular.
Yeah, I think so. I think most people will be familiar with those from seeing them in other GIS packages like ArcGIS, and probably QGIS as well would have something like that, I guess.
Right. And so we'll just cover them briefly. Equal intervals takes the range of values and divides it up equally. So if your if the values on your features ranged from 0 to 100, and you said I want 10 classes, your first class will be all of the features that have a value 0 to 10, and then 10 to 20, and then 20 to 30. This has the effect of keeping your class ID directly proportional to the actual value on your feature. But it can, for instance, leave you with classes that have no features in them.
Right.
You have empty classes, and the number of features in your classes can vary wildly. Like I say, from none to all.
I can see that, yeah.
Quantile is sort of the direct opposite of that. Rather than having an equal range of values, and the number of features could vary, it instead says each of your classes should have the same number of features, sort of regardless of how their values range.
Okay, that makes sense, yeah.
It isn't the case that they all have an identical number of features. If you have an odd number of input features, some of your classes may have one fewer than the rest.
Yeah.
The intent is that it's as close to equal as possible.
As it can get, yeah.
And then natural breaks is probably the more interesting one. It is built on top of an iterative algorithm that attempts to select interval boundaries that accurately capture clusters of data, clusters of features that have a similar value.
Okay.
And so what it essentially tries to do is select classes that minimize the difference in values between features in that class and maximize the difference between features in different classes. The effect of this is that clusters in your data tend to be put into the same class, and distant outliers will often get their own class, even if there's just a few of them.
Okay. Interesting.
Some people might know this by a few different names. Jenks optimization is a common name for it.
Yeah.
It's essentially a one-dimensional k-means clustering algorithm.
That's the sort of detail I love to hear. It doesn't mean a lot to me totally, but I do like to know that. At least I can go and look it up afterwards. Yeah.
Yeah. But yeah, quantile, equal number of features per class, equal intervals, equal range of values per class.
Okay.
And natural breaks tries to be smart about selecting classes that capture the natural clusters in the data.
Gotcha.
Once we have done that grouping, the output is just an attribute on each of the features, specifying an ID for the class it was placed into.
Excellent.
And so in this workspace, we are making use of that. What I've done here is collected some Canadian census data, pulled out population density values for each of the regions that the census data is grouped into. And then we are classifying those regions based on their population density using each of the modes.
Okay.
And this bottom one here, the statistics calculator, I'm just using the value directly to color the features.
Okay.
And I'm feeding that class ID output into the FeatureColorSetter to produce a gradient across the class values. Excellent. So the interpolation value being used for each feature is just its class ID divided by the number of classes here.
Right. Yep.
And so we'll be producing a gradient from sort of a light purple to a darker saturated purple. And we can take a look at how it shapes up. So this is an area of southeastern Canada. And what we're displaying here is just the unclassified, doing a color gradient on the actual population density values. And so you can see there are some extreme outliers here in the dark purple. And most of the regions are very similar in their value relative to the total range of values. If we look at equal intervals, and excuse the delay here, I'm running this on a remote machine.
Yes.
Okay,
go
like
ahead.
I was saying before, the class that you are assigned to remains directly proportional to your input value in equal intervals because it's just directly sliced. And so we really don't have much additional separation here. What you can really see is that all of the sort of low value similar regions now have actually identical colors. So we've actually flattened most of the separation. If we use natural breaks instead, it will try to find clusters of similar values and give them more distinct separable colors as a result of being in different classes. Even if the original data wasn't that far apart, this gives us a better glimpse of regions that are similar in terms of their population density, while still maintaining, to at least some degree, proportionality to the input values.
Oh, that's cool.
And the most extreme case here is quantile, which will essentially write off proportionality to the input value in favor of having a good spread across the different classes. And so we'll see a lot of separation, representation of all of the different colors across the gradient here. But definitely no longer proportional to the input, as you can see.
Definitely not. No, this really is classifying something in a class, not a scale, I guess.
Yeah,
that's interesting.
And so maybe not as useful for choropleth maps, but I'm sure that there are many other use cases for being able to quantile classify your data.
Yeah, I think so.
But yeah, that was the original
fantastic
Innovation Days project turned feature.
That's great. We got a couple of questions, but maybe do you have my workspace open, the one that I sent?
I do.
Perfect.
This is right here.
Okay. Okay, well, one of the questions was, can you use a classifier to divide the data into groups to use with the group by setting? So I think, I think, because I mentioned this to you, in the documentation it says, the first line says something about sorts and some things to data, but it doesn't really sort it. It's only sorting it for the purpose of creating a group. So, I mean, I guess once you've got that group ID, you could run it through the sorter to put it into an order. And then all your future transformers are going to have that. If you use a group by option, you can group by that and improve the performance. So
yeah. So if you wanted to use group by in sort of a functional way, like we're using it in the dissolver or something, and you want to dissolve regions that have similar values together so that you could then display them as one block. This could totally fulfill that purpose. You can produce the class ID, use that, produce your groups, and then have your output be functionally different. For performance, like Mark, you were saying,
does that
you probably would want to then sort by the class ID to get them consecutive.
And then you've got that setting in the group by which says change group when group by value changes, and that would
so that we don't have to accumulate them all until the end and then run them all through.
So I mean, I guess I've never thought to try that, but I guess you could try the classifier versus something like the modulo counter, which is the other way that I'd sort of create sort of false groups for processing like that. I've got no idea which is faster, but
I imagine the classifier will probably be useful in cases where there is like meaningful clusters in your data that somehow
that's true
would affect the processing, where grouping things by that data produces some effect.
Yes, that's true. well, it's often come up that we group by data geographically in some way, and this is probably a good way as any to do that.
Yeah, there's another way of doing that. I don't actually know the name of the transformer, but it's probably
Spatial sorter. Yeah, I think that one's
something
the
called
other.
a
Yeah,
sort, which is probably one of the more effective ways of accomplishing that.
Yeah.
If you're trying to optimize input to things like dissolve or other spatial operations.
yeah, that's a good one. So, I mean, with this one I've got here, this data just came from the city of Winnipeg. It's a whole bunch of CSV records about trees, and I just put it through the classifier to see what comes out of it. And I'm using a user parameter for the number of classes, the diameter at breast height. So I guess it's sort of talking about 4 feet high, what the diameter of the trunk is at that point. And I'm putting it into a class called tree diameter class, so we can obviously change that name. What I found interesting is that you can send that through the statistics calculator, and that will tell you what groups you actually got out of here, like what's the minimum value of each group, what's the maximum value, and what's the total number of features in each group. Because what I've done now is I've got group by class and analyze the diameter, which is the attribute I use to create the class. And so the nice thing about that is, yeah, it'll tell me for each class what the minimum, maximum value is and how many features are in it. So if it was quantile, then it would have the same number of features in it.
But as close as possible.
Yes, and then the min and max values would be sort of wildly different. Or the range, actually, there's a range setting in there that would be wildly different. But I guess in the other one, the range value will be the same, but the total count would be different. So yeah, if folks go away and try this out, have a go at the statistics calculator and try changing the settings and see what it does. That's to me was the best way of showing things for that. Then yeah, I just put a buffer around things and colored it. And can we have a look at the color setters that I use?
Sure.
Okay.
Here's the first one.
Yep. So that was okay. So I was just creating random colors there, I think.
Yeah, random color for each class.
But for each class, yeah. So that's another way. So we should probably mention this, that it's not necessary that you use the classifier with the feature color setter all the time. You can just use the classifier by itself if you wanted to. And you can use it for other settings inside the feature color setter, like random. So each class gets its own. And this one was, again, totally the same as yours. You start with one color, end with another, and the interpolation value is number of classes minus 1. Which I think is going to be a very common thing, because you want to take
it's worth mentioning that the class IDs are 0 based.
That's, yes. I was just going to say
if you have 8 classes, it ranges from 0 to 7.
Yeah.
So divide by 7 to get your gradient. Yep.
Yes. So that's why that would be the case there. So yeah, that's all I was doing, and then you get the range of colors for very light for small trees up to dark green for larger trees. Yeah.
So there's the input, a bunch of point locations for the trees with their data.
Yeah. They're just a whole bunch of points.
This will be the gradient output.
Okay.
Ranging from white to green.
Yep.
I can maybe bump up.
Yeah. It's I picked trees. Trees were probably not the best demo of this. You don't actually see a lot. Or I could have made the buffer a bit bigger, but whatever. It's we can see a nice range in there.
And then here's the randomly colored.
Yep. And we must be using quantile with that because it's all the same number of features in each group.
Yeah.
Yeah. So yeah, lots of ways to use that data. I really love the classifier. It's something I think we've needed for a long time and haven't really had that capability. So it's
and like you said, it doesn't necessarily have to be used just for coloring. I could imagine a use case where you want to classify your data into groups with similar values to then pass them off into different buckets for your output.
Yeah.
Um,
Oh, sorry.
Go ahead.
No, the classifier transformer. So I assume, and I'm sort of going on to question what somebody's asked here in the chat. I assume that it only works on, say, vector features or things like that. You can't run it on a point cloud, for example.
So it needs to work on individual features,
Right.
but the geometry of the feature is irrelevant. It works entirely on
Okay.
the attribute
Okay.
or arithmetic
Yeah, that's what I.
that you use to produce the value per feature.
Yeah.
If you took your point cloud and split it into, like converted it to a multi-point and then deaggregated it into individual point features, you could then classify all the points by some metric, the x coordinate or some combination.
Yeah.
Yeah.
Okay, that makes sense, I think. Yeah, because with point clouds, you don't get attributes as such for each point. You get I
One
can't
for the
remember what they
whole.
call. Yeah, you sort of get individual values for each point, but they're not called attributes and they're not accessed the same way. So I don't. Yeah, I didn't see that it would work like that. And I suppose the colorizing thing would be the same way, same thing. You can't really color a point cloud, excuse me, with the range because same deal. It's they're not separate features. So yeah, someone was just asking about that, and I really don't think that would work like that. But if you really felt there was a need for it, then let us know.
If you're just messing around, yeah. I'm sure there's lots of clever stuff you could do.
I'm absolutely certain there is. Yeah. Can we just go back to my workspace for a second?
Sure.
I just wanted to mention as well that there is a group by setting in the classifier. So, for example, in here, we could turn on group processing, and I've got an attribute called, let's see, electoral ward. I think that's there. So there's 8 different wards or electoral areas inside the city of Winnipeg. And when you do that, it'll run the classifier on the trees in each separate ward separately. So I guess you get the same number of classes for each one. So instead of having 8 classes for the whole city, you'd have 8 classes for every different electoral ward that there was.
Yeah.
So don't want to forget that you can do that because it really is another useful piece of functionality that's in there.
Yeah. And there's one thing that I think is probably worth mentioning. I personally discovered it after the fact, but there is a hub transformer called the graded colorizer, which offers functionality similar to this sort of workflow.
Okay.
But these new built-in transformers sort of loosen a number of the limitations of the hub transformer.
That's fair enough.
This did already exist and maybe was used by some people, but it provided a sort of fixed set of gradients that you can select from.
Got it.
The new FeatureColorSetter lets you do arbitrary gradients.
Okay.
It didn't have natural breaks, which we now offer, and I hope will be useful.
Yeah.
And the fact that it was sort of linked together, you had to do your classifying with your coloring.
Okay.
You couldn't get the class ID as an output to do things like output bucket filtering. Hopefully makes this new solution more flexible for people.
I think so, yeah. I think that's why a lot of people, especially the type of people who come onto a presentation like this are the type of people who appreciate that flexibility, I think, and the fact that they can just stack things together to create a cumulative result. And I expect it's faster as well, the new functionality.
Certainly.
Yeah, should be. Well, that's fantastic. If there's any last second questions, do type them into the chat, folks. But I think it's fairly straightforward, but it's really good to especially have the developer who wrote all of this online with us. So it's much appreciated, Jeff. Was there anything else in FME 2023 that you were involved in?
Well, this was a sort of personal project of mine based on the prior Innovation Days project, but the geometry team as a whole spent most of our time in FME 23 working on bulk mode performance.
Right. Yes.
There was a large sort of company-wide initiative to really step up our game in that domain, and I'm sure that folks have heard about that through other presentations already, but that's where a lot of our time went in 23.0 specifically.
Yeah, I mean, I'd heard the numbers are way better for performance in 23, so that's great. Yeah.
I was also personally involved in the data inspector performance.
Right, that was one I really knew about. Yeah.
Project for 2D rendering. Yeah.
And that was I think we. Yeah, I was talking with the user about that. Yeah, about why we did that and how better it was. But yeah, it was something like 1.5 times faster to read just flat 2D data, I think, and 3 times faster for non-spatial. Is that something like that?
Depends a lot on the data, and a lot of the wins for that specifically were around like panning your view around and reducing the number of redraws and increasing the speed of those redraws.
Yeah, that I mean, yeah, I don't know about the users, but I'm sure that I've seen an improvement in that, definitely. And if it's looking slow today, it's like you said, you're on a machine that your remote desktop to controlling it with a third machine, streaming it onto my meeting, and I'm streaming it out to Twitch. So that's, if anything's a little slow, that'll be why. But
an interesting setup we've got.
Yeah. Oh, that's fantastic. That's great to know that you're involved in that, because I think a lot. Yeah, more performance is always welcome, is what folk have said. So, I actually on that topic, maybe you don't have an answer for this, but I've heard people before say, well, we should perhaps put it in the documentation whether a feature supports bulk mode or not. A transformer supports bulk mode, but I'm thinking that most transformers will now. It must be pretty rare that there isn't a transformer.
Yeah, that's been a goal of ours over the past more than a year, I guess, at this point. Like I was saying, like most of our effort from the geometry team for 23.0 was centered around accomplishing exactly that goal, having all of the transformers support it. So ideally there won't be transformers that don't support it.
That's what
there may be some that support it to different degrees. Like if a transformer is reordering its output or doing something like that, that prevents us from really cleanly making use of the sort of bulk mode technology behind the scenes, then it may benefit less from bulk mode, but there shouldn't be any transformers going forward that
it won't spit out non-bulk mode features for the most part. That's for sure.
Yeah.
So that's what I figured. Yeah. So yeah, I mean personally, I don't think we need that documented anywhere, because it should work. And this is probably before you were at SAFE, but we had the same thing with geometry. We had like old geometry and new geometry, and
classic and rich. Yeah.
Yes, that's right.
You're familiar.
Exactly. Yeah, and for the long time we kept saying, well, which one's classic, which one's rich, and it just sort of all became rich in the end. So same thing's going to happen with this. Yeah, if it's not already.
We actually just recently finally completely removed the concept of classic geometry from FME. So even behind the scenes, it is no longer a thing. We're all rich.
Excellent. Love that. We all love being rich.
Yeah.
Well, that's great. Thanks again, Jeff. That's really great. Great for you to come to here today, and great for users to meet you and see what our developers are up to. So
it's been fun.
Yeah, good. And next week, I'm not sure. I'm definitely going to have something next week. I think it might be on the user parameters, the conditional user parameters. If I can find someone to come in and talk about that, I will do. So that's what I'm going to try and do next week. But
great.
Yeah, well, thanks, folks, for tuning in. Thanks to Jeff again for showing us all this. And I'll say goodbye, and we'll see you next week. Okay, thanks,
awesome.
folks.
Thanks.